when you solve for a variable, it's important to pay attention to what things are done to that variable. So here is our variable that we want to solve for. And to a, first b is added. So this is the first thing that's done. Let's put number 1. And then it's multiplied by 1/2, number 2. And then h is multiplied. Because multiplication is commutative, you could also think of h being done at the second stage, and then lastly 1/2 is done. But it doesn't matter. At the end of the day, the answer will be the same. But once you figure out what kind of operations are done, then you want to undo it by reversing this process. It's like if you ever built an electronics and you want to take them apart, you want to unscrew the last screw that you put in, and then you start undoing these things in the reverse order, right? So because I'm saying that h was done last, I'm going to divide both sides by h. So I'm going to, whatever that was done last should be undone first. So I'm going to divide by h. And the reason I'm dividing by h is because h is multiplied, and the opposite operation of multiplication is division. So that's why I'm dividing by h. So I divide by h, and now I multiply by 2 both sides. And the reason is this 1/2 has the multiplicative inverse as 2. They cancel each other. So that now 1/2 is gone. Let's see what we have so far. You have 2a over h, because when you multiply a number to a fraction, it only gets multiplied to the top. And then you have a plus b. Oh, okay, so the only thing that's left is the first thing that you did to a, which is b. So you subtract b both sides and you're done. Now here you have to be very careful. You're subtracting from this. So what you get is you get 2a over h minus b equal to a. That's what you get. Okay, let's do the next question. So we're trying to solve for y here, and y is right here. So s is multiplied, that's done first, and then u is added, and it falls under c. But before we do this, actually, there's another thing I request for you to do. Anytime you see a fraction, then it's good to multiply that denominator both sides so you can get rid of that fraction. In fact, in the previous question, since we had this fraction, you could have started the question by saying you have a fraction, and fractions are evil, you don't like them, so we multiply it by 2 both sides, and they cancel, and you have 2a equals to a plus b times h, and then you can start solving by dividing by h, and then subtract b. You'll get the same answer that way. So the same story here. You want to multiply sy plus u both sides, and be careful. You're trying to multiply this entire thing to both sides, so you definitely need this parenthesis. Number one source of mistake in algebra is probably the plus minus sign, and the second one is parenthesis. So many mistakes are committed because people forget about parentheses. Okay, so on the right side, I'm going to multiply sy plus u, and left side also sy plus u. And because you've multiplied and this is a division, they cancel each other, and you get sy plus u times k equals to c, and our evil fraction is gone. Very nice. Okay. All right, now let's try to see the order of operations. This one is done. No, first s is multiplied to y, so that's done first, and then u is added, and then k is multiplied. So that's the last one that was done. So we're going to start removing stuff from y, doing the reverse order, which is sy plus u times k, and then you divide both sides by k. So I'm getting rid of k first. Oh, I have to divide both sides by k. So both sides are divided by k, but this k is gone. Then the result is sy plus u equals to c over k. And then u is added both sides. Well, again, I want to stress that to y, s is multiplied first. The order of operation is this s first, and then this u is done second. So it's this u that has to go away first, okay? So if sy equals to c over k minus u. By subtracting u both sides, this is what you get. And lastly, you just have to divide by s, so y is equal to c over k minus u divided, the entire thing divided by s. Now you still need to simplify this, and the reason you have to simplify this is because there is a fraction inside a fraction. You need to get rid of these small fractions, and the way you do it is by multiplying by k top and bottom, because when this k gets multiplied to each, let me show you what that does. This will be c over k times k minus u times k over s times k, and then see this k and this k, they cancel each other, and therefore you end up with c minus uk divided by s k, and that is the final answer. This is y. Here we have to solve the quadratic equation by factoring. Now I know that a lot of you have trouble learning this factor by grouping. So let me try it in two different ways. If you are lucky, then you might just be able to just factor this by trial and error. So here's how you do it. You think about 2x squared. 2x squared is 2x times x, right? It doesn't matter if you put x and 2x or 2x and then x. The answer at the end of the day will come out the same thing. And then what you do is, well, here's the general theorem. If you have ax plus b and cx plus d, and if you do the FOIL first, outer, inner, last, and if you do that, then ax times cx gives you acx, and then you have ax times cx is ax squared. Then you have a times d, adx plus bcx, then b times d, which is bd. And then since these are numbers, and x is the real deal here, since they have the same x, I'm going to factor the x out. And that's the general formula for what happens if you multiply two binomials in this way. And if you look at what this is, AD plus BC, that's like multiplication of the outer and then multiplication of the inner. So in the FOIL, first, outer, inner, last, this OI thingy, which is the outer and the inner. These two create this middle term. Okay? So you just have to remember that. Okay? We're going to go back to that. Then now to see what this last constant term is, this thing is really these two numbers multiplied, right? Okay, so you really have not many choices here. If you think about it, it could be, see, two numbers that multiply to 5. It could be 5 times 1 or 1 times 5. And let's see, just pick those numbers and use this formula. It should be outer and then inner, you add them, right? The outer gives you 2x, the inner gives you 5x. 5x plus 2x is 7x. Oh, but that's negative 7x. Oh, you know what, if it's plus, there's no way you're going to get minuses, right? So minuses are out of the question, therefore they should both be negatives. These should be negatives. So if these are negatives, two negative numbers that multiply to 5 is, it can only be negative 5, negative 1, or negative 1, negative 5, right? And if you try this first one, 2x times negative 1 gives you negative 2x, negative 5 times x gives you negative 5x, so if you add them together, you are going to create negative 7x. So we got it in the first try. And just to check what would have happened if we chose this first, then 2x times negative 5 would be negative 10, negative 1 times x, that would be giving you negative 11x. That's different from this, so you would know that it's not right. Okay, so sometimes you get lucky, and you just simply have these factors by trial and error. This is especially true if these numbers don't have a lot of factors. If this 5 was something like 12, 12 has so many factors and it has so many different possibilities, it just becomes overwhelming to do it this way. Okay, but anyways, let's proceed. What would that be? 2x minus 5, x minus 1 equals to 0. When a bunch of numbers multiply to give you 0, at least one of them has to be 0. So either 2x minus 5 is equal to 0, or x minus 1 is equal to 0. Add 5 both sides, and we get 2x equals to 5, divided by 2, so you have 5 over 2. Over here, you just add 1 both sides, you get x equal to 1. So you get these two answers by doing this factoring. Okay, as I promised before, let me try to show you how to do this the right way, or the formal, official way. That's called factor by grouping. And it works like this. The factor by grouping is you multiply the first number and the last number, which is 2 times 5, which is 10. And you look for the two numbers that multiply, I shouldn't say A and B, I'll use capital A and B. So two numbers that multiply to this product that you just made, and two numbers that add to the middle number, negative 7. Well, 5 times 2 is 10, and 5 plus 2 is positive 7, so it must be negative 5, negative 2, right? So you can conclude that the negative 7 should be broken as negative 5 and negative 2. Just like that. Okay. Once you have identified what your A and B must be, then what you want to do is you want to replace the middle one as 2x squared plus negative 5 plus negative 2x plus 5 equal to 0, and then you multiply, and you get 2x squared minus 5x, and then minus 2x plus 5. Okay. Now these two have the common factor as x, and if you factor x out, this is what you get. And these two, whenever you have a minus, you have to factor that out, so you have negative. If you factor out a negative, it becomes 2x minus 5. So what I just did is what we call factor by grouping. Once you split the middle term like this, then you group the first two and factor as much as possible. Group the second two second set of two, and then you factor much as possible. And then the result is you end up with the same thing here and there, which means you can factor that again. So if you factor out a 2x minus 5, then what you're left with is x from there, and then this is negative 1 times 2x minus 5, so it would be negative 1 equal to 0, and this gives you the same kind of factoring, so at the end of the day, this will be your answer. This will be your answer. Okay, let's try this next one. Yeah, this one would be a challenge, right? Plus x minus 12 equal to 0. You first want to move everything to one side. If you're doing quadratic equation, you want to move everything to one side and order it by its powers. And then what we do is we multiply these first and second two. Well, let's try to see if we can actually do the trial and error stuff first. So how do you get 6? You could get 6x squared by 6x times x. Or it could also be 3x times 2x. So you actually get two possibilities. So already the possibilities are kind of hard to track. And then negative 12, that's like 6 times 2, 3 times 4, what else? 1 times 12? Yeah. All these. I think that's it. Yeah, 6 times 2, 3 times 4, 1 times 12. Alright, so that's all the possibilities, and because you need to get negative 12, it could be negative 6 times positive 2, or it could be positive 6 times negative 2. It could be 3 and negative 4, negative 3, and also it's possible to have these two switched. So you end up with so many different possibilities, it'll be very hard to do it this way. So that's why when numbers are like these, when they have a lot of factors, instead of trying to do it trial and error, it's better to try to do factor by grouping. So let's do the factor by grouping. 6 times negative 12. What's 12 times 6? 6 times 2 is 12. 6 times 1 is 6. 6 plus 1 is 7. 72, right? So we need two numbers that multiply to 72, and two numbers that add up to that middle number. Well, there is nothing there, but it should be thought as 1 times x, right? It's 1 times x, so we're looking for it to be equal to 1. Oh, so there's something I forgot. When you multiply the two things, you have to include the negative sign if it's there, so you need this negative sign. Alright, so you have this a times b equals to negative 72, and a plus b equal to 1. Well, I just remember that 9 times 8 is 72, and how convenient, because if you had 9 times negative 8, there'll be negative 72. Also, 9 plus negative 8 gives you 1. So awesome. So now what you want to do is replace that 1 as 9 plus negative 8. Since a is 9 and b is negative 8, replace it like that, and replace your x, which is 1 times x. There'll be 9x plus negative 8x. Alright, so you take this thing in the middle, you replace it with this, and let's see what we get. We get 6x squared plus 9x plus negative 8x minus 12 equals to 0. And then this thing, you have to factor, well, they're both divisible by 3, so I'm going to factor out the 3. And also, they're both divisible by x, so I'm going to factor an x out. And the result is 3x times 2x gives you 6x squared, so I'm going to put 3x times 2x. And 3x times 3 gives you 9x, so it should be plus 3. Okay, in the second set, if there's a minus, you have to factor a minus out, and the common denominator of 8 and 12, common factor of 8 and 12 is 4, right? 4 times 2 is 8, 4 times 3. So that's the greatest common divisor of 8 and 12 is 4, so I'm going to factor 4 out, and that gives you 2x plus 3. And we're almost there, because now, again, you see this 2x minus 3, 2x plus 3, 2x plus 3. So you factor that out. Factoring that out, if you take them out, then the remaining ones are 3x and then negative 4. So now you can solve this by saying either 3x minus 4 should be equal to 0, which is, if you add 4 both sides, it's this, and then divide by 3, you get x equal to 4 over 3. In here, 2x, well, you're trying to say 2x plus 3 equal to 0, so subtract 3 both sides, and then divide by 2, you get negative 3 over 2. So these are the answers. answers. These two are the answers. Number 3, solve the following equations. You must simplify the answer. Uh-oh, we have fractions, right? Whenever you see fractions, you have to know fractions are evil. They're the ones that gives you all the headache in algebra. So what you want to do is you want to get rid of the denominators by multiplying by those denominators. So let me show you how that can be done. You are going to just copy down this thing. Give you some room there. And then I'm going to multiply 2 times x minus 2 to the entire thing. So entire left side gets multiplied by this, and also entire right side gets multiplied by 2 times x minus 2. And the reason for that is this 2 is going to cancel this 2 away, so this won't be a fraction anymore, and then this x minus will cancel this x minus 2, so this one won't be a fraction. And it'll work, okay? So let's see, we multiply them out, so you get 2 times x minus 2, 2x plus 5 over 2, minus 2 times x minus 2, 3x over x minus 2, 2 times x minus 2, times x, okay. And then 2 and 2 cancels, x minus 2 cancels, and, oh, you have to be careful, this x minus 2 is being multiplied to this entire thing, right? So after canceling, you need to put this parenthesis. So many mistakes in algebra is made by forgetting a parenthesis. So this is what you have. On this side, negative 2 times 3x, that's easy, it's just negative 6x. Let's multiply 2 times x together, so you have 2x and then x minus 2. And we will need to do the FOIL here. First, outer, inner, last, FOIL. X times 2x gives you 2x squared. And then x times 5 gives you 5x. Negative 2 times 2x gives you negative 4x. Negative 2 times 5 gives you negative 10. Minus 6x. On this side, 2x times x is 2x squared. And 2x times negative 2 is negative 4x. Okay? Negative 4x. Okay. Combine like terms. 5 minus 4 is 1. Minus 6, that'll be negative 5. So you're going to get 2x squared minus 5x minus 10 here equals to 2x squared minus 4x. And then I can subtract 2x squared both sides because they're the same thing, right? So they are going to cancel. And that's nice because I only have now negative 5x minus 10 equals to negative 4x. And if you have more than one x and you have to solve for x, what you want to do is you want to move all the x's to one side so that you can simplify. So I'm going to add 5x both sides. So you get negative 10 equals to negative 4x plus 5x. But wait a minute, 5 plus negative 4, that's just 1, so you get x, which is equal to negative 10, so that is our answer. Another fraction, okay. Now, in the previous one, I said, well, if you see x minus 2 in the denominator, you multiply by x minus 2. Since I see an x there, I'll also multiply by x. And since I see x squared minus 2x there, I'll multiply by x squared minus 2x. That's how I would have been doing this question if this example was the only one I remembered, or only one I know. But this will make the question really hard to solve. You shouldn't do this. Instead, what you want to do is see that x squared minus 2x can be factored by an x, right? If you factor an x out, that's x minus 2 times x. And that's nice because if you write it like 2x plus 1 over x minus 2 plus 3 over x equals to negative 6 over x times x minus 2. We just figured out that this denominator is this. then when you get to multiply both sides, you multiply by x in order to get rid of this x, you multiply by x minus 2 to get rid of this x minus 2, but if you multiply this, this is the same thing as this one anyway, so this is also going to cancel away. So that's nice. You don't have to multiply so many things. You can just multiply x times x minus 2, and still all the fractions will be gone, and you will have something easy to solve. If you multiply too many things, then the resulting thing is still ugly. So you really want to be cautious about reducing what you multiply. Okay, so we have 2x plus 1 over x minus 2 plus 3 over x equals to negative 6 over x times x minus 2 times x times x minus 2. On the right side, it's immediately seen to be canceling. On this side, you have to multiply this to 1 and then another. So what's that? That's x times x minus 2, 2x plus 1 over x minus 2, plus x times x minus 2, 3 over x equals to negative 6. And over here, on the left side, x minus 2 cancels. On the right side, x and x cancels. And the result is you have x times 2x plus 1 plus 3 times x minus 2 equals to negative 6. Let's see, let's expand them. It's 2x squared plus x. Expand them, that's 3x minus 6 equals to negative 6. You can add 6 to bring everything to the left side. So this is a quadratic equation. That means you want to bring everything to one side in order to solve. So I'm going to add 6 to bring that 6 to this side. But then over here you see that these two cancel too. So you're going to get 0, 0. Meanwhile, x plus 3x is 4x. So what we get is 2x squared plus 4x equal to 0. And they're both divisible by 2x. So I'm going to factor 2x out. And the result is you get x plus 2 because 2 times 2x gives you 4x, right? X times 2x is 2x squared. So this is exactly the same thing as that. And for that to be equal to 0 and you have a bunch of things multiplied, each one of them, at least one of them has to be 0. So either 2 is 0, which is ridiculous. It can't happen, so that can't happen. Or x could be 0. Or x plus 2 could be 0, in which case x must be negative 2. So from this, we see that the answer is x equals to 0 or 2, but yeah, so I should have been doing that even in the previous one, so I forgot that. Whenever you have an answer, you have to go back and plug it in to the original equation to see if it works or not. Here, well, I knew that this is indeed the answer, so I stopped here, but really you have to do a check afterwards, okay? So over here, let's do a check. Is x equal to 0 a solution? Well, it can't be a solution because if you plug in 0, you get 3 over 0. And having a 0 in the denominator is a big no-no. You can't divide anything by 0. Okay? So if you are not understanding why dividing by 0 is bad, if you have an iPhone or somebody with an iPhone, try Siri. Hey Siri, why is 1 divided by 0 bad? And Siri is going to give you some really funny story or something like that. Yeah. My son likes to hear that all the time. Hey Siri, what's 1 divided by 0? Yeah. Oh, no.
Please don't make me divide by 0.
Okay, sorry, that was my iPhone responding. Okay. Alright, okay. Alright, going back, so 0 is not allowed, and then, so 0 is a no-no, because it makes this thing 0, so 0 is a no-no. And then, when you try to plug in 2, if you have 2 minus 2, that's also 0, so that's also a no-no. And, so, what does that mean? That means there's no solution, right? So, actually, this is not the answer. The true answer is that answer, no solution. Okay. All the solutions that you get are extraneous solutions. So all solutions are extraneous. So these solutions are that are not true solutions. You get something by algebra, but when you actually plug them in, it makes the denominator equal to 0, and therefore they are not allowed. So those things do happen. Okay, solve the following inequalities. Let's try these inequalities. The first one is just a simple inequality. You would just solve exactly like how you would solve an equality. You would subtract 7x both sides and add 9 both sides. 3 plus 9 is 12. Still inequality, and then not negative 9 plus 9 that cancel, so it's gone. 7x minus 7x, that's gone, so you only have 12 on this side. 9x minus 7x, that's 2x, right? And then you just divide both sides by 2 and you're done. So you get 6 less than or equal to x. So that's the answer to part A. And when you do this, the only thing that you have to be careful is sometimes if you divide by negative or multiply by negative, then you have to flip the inequality. Yeah. Here we didn't have to do that because we're just dividing by positive numbers, but be careful. Sometimes you end up dividing or multiplying by negative. In that case, you have to flip the inequality. All right, in part B, you have a case where 2 inequalities are solved. Now, one way to solve this would be solve the first inequality and the second inequality separately, but it's easier to just solve everything at once. So, how do you solve everything at once? Just add 9 to every place. So all these parts will have plus 9. All of them are added 9. So 4 plus 9 is 13, 3x, and then 21 plus 9 is 30. And then, see, the goal is to isolate x. So we first got rid of negative 9, and now you have to get rid of 3. And, of course, you would divide by 3 in order to isolate x, and they cancel. 30 divided by 3 is 10, so you end up with x has to be less or equals to 10, and it has to be greater than 13 over 3. In pre-calculus, we always use improper fractions over mixed fractions, so you have to leave it as 13 over 3. You shouldn't write down 4 1/3. Alright, so this is the answer, and if you're interested, you can also write the answer in terms of a interval notation. In interval notation, you can say that the solution is from 13 over 3 not included until 10 including 10. So that's another way to write the answer. Let's try this next one. These are quadratic inequalities. Now, whenever it's not those simple linear inequalities, the inequalities become super hard. And, I mean, you shouldn't try to solve the inequality. You should always try to solve the equality first. And then, using the information from equalities, you should attempt to solve the inequality. Alright, so let's try that. First, you want to solve, so for C, you want to solve x squared minus 2x minus 4 equal to 0. And you might try to factor this, but you have to get two numbers that multiply to negative 4 and add to negative 2. Well, 4 is 2 times 2 or 1 times 4. Neither of those will create 2. So this, unfortunately, is something that you cannot factor, which means you will have to use the quadratic formula. Now, I noticed that even after years of algebra, people forget the quadratic formula, and I have to stress this. You shouldn't come to take the exam if you forgot the quadratic formula. It should be something that everyone who's taking algebra and pre-calculus would know. And it's not hard to memorize it at all. There's even a song, right? So you can say x equals to negative b plus minus square root b squared minus 4ac all over 2a. Yeah, so this is how you do it. Okay, to use this over here, you think of x squared as 1 times x squared. So a is 1, b is negative 2, c is negative 4. So let's compute with this. b is negative 2, so it's negative of negative 2 plus minus square root negative 2 squared. These parentheses are super important. Forgetting them would make you make mistakes and cost you a lot of points. Okay, a is 1, and then c is negative 4, over 2 times 1. Negative of negative 2 is positive 2, plus minus. Squaring of negative gives you positive, and 2 squared is 4. There's a minus here, so these two negatives gives you positive, right? This should be positive, and then 4 times 4 is 16 over 2. And you want to simplify this as much as possible, because without being able to simplify this, you would be at a loss what to do. So you simplify this. Well, simplifying a square root means identify any square factors. Square factors are like perfect squares, like 4, 9, 16, 25, 36. I mean, these are, 36 is like 6 squared, so those are square numbers. Whenever you have square numbers, those have to be brought outside the square root. So you have 20, which is 4 times 5, right? And 4 is a square number, so 4 can be brought outside the square root. And because square root of 4 is 2, this becomes 2 plus minus 2 times square root of 5. Okay, over 2. And then, do you know this thing, share the heart? Share the heart. You take, if you have more than one term on the top, and then you can say first over the first over the denominator, and the second over the denominator. That's how a fraction can be split into two fractions. So it's like 2 over 2 plus or minus 2 radical 5 over 2. And then you can see that this 2 over 2 is just 1, right? So you end up with 1 plus minus. And then again, 2 and 2 cancels. 2 divided by 2 is just 1. So you end up with 1 plus minus square root of 5. So in other words, to continue with C, you need to solve the equality, and you get the answer as x equals to 1 plus square root of 5 and 1 minus square root of 5. Okay. So we solved the equality. Now what? So these are the solution of equality, not the inequality, it's the equality solution. So now what do you do? Well, put them on the number line. So we have, well, 1 minus square root of 5 is less than 1 plus square root of 5, so I'm going to put 1 minus square root of 5, then 1 plus square root of 5. Then what you want to do is you want to pick a number. So in this number line, you want to pick a number from each interval. See, these two numbers, once we pick them, divides the entire number line into 3 intervals. There's one interval, another interval, and this third interval. And what we're going to do is, like, we're going to take sample points and test them. It's just like, let's say you have a water treatment facility in your town. They have 3 pools of water, and some guy wants to make sure that the water is clean. So what do? You pick a small sample from here, another sample from here, another sample from here, and then test them, right? So that's what we're going to do. So we're going to put some numbers. A lot of times I like 10 because it's easy to calculate. So I know that negative 10 is definitely less than 1 minus square root of 5. Square root of 5 is like, it can't be 3 because 3 squared is 9. So this is way bigger than negative 10. So negative 10 definitely belongs on this pool of water. Interval. This interval. And then, see, you have 1 minus some number, 1 plus some number. So at the middle, there will be 1, right? 1 will be right in the middle between the 1 minus and 1 plus. Okay, and then 1 plus right equal 5. After that, there will be positive 10. Because this is no way it can be bigger than 10. So 10 times, I'm going to put positive 10 as my sample choice. Now these are not absolute. Actually, if you are very careful, you'll also see that 0 belongs here. So you could have chosen 0. You could have chosen something like negative 3 for this sample here, and then positive 4 or 5. That could also have been a possible choice. I'm just choosing something that's easy to calculate. Alright, so now I'm going to test the inequality for each one of them. So negative 10, what do we do? So for negative 10, if I plug in negative 10 squared minus 2 times negative 10 minus 4, and squaring a negative 10 gives you positive 100, right? And then negative 2 times negative 10, that's positive 20, and then minus 4. Is this bigger than 0? Yes, it is, right? I don't even want to calculate what that is. I'm just being lazy here. But this is way bigger than 4, so it must be positive. So it's a check. So this works. Okay. So the guy who is sampling water is happy. And this one's okay. Okay. All right. Now let's plug in 1. Let's see what happens. You plug it over here. 1 squared minus 2 times 1 minus 4. 1 squared is 1. 1 minus 2 minus 4. Hey, I think the negative has it, right? You have more minuses, so this will be negative. So this is a no-no. It's bad, okay? It does not satisfy this inequality. Right? We need something that satisfies this inequality, and to satisfy this, it has to be bigger than 0. That's what it said, right? But this does not satisfy this inequality, so it's not true, right? Okay, and then when you pick 10, 10 gives you 10 squared minus 2 times 10 minus 4. That's again 100 minus 20 minus 4. Oh, that's still positive. Okay. So that's okay. So we know that this is okay, this is a no-go, and this is okay. Right. So now we are ready to give you an answer. I've used up all the space, so let me just write the answer somewhere right here, over here. Answer would be, your x value should be over here. What's that? That's before 1 minus square root of 5. And, or it could also belong here, which is after 1 plus square root of 5. So that's the answer to the inequality. Let's try the second one. Again, you won't be able to solve the equality just by factoring. You will have to use the quadratic formula. I usually don't like having negatives there. I'm going to multiply negative 1 so that it's positive x squared minus x plus 5. Oh, in that case, this does not have an answer, right? Well, I found it really quickly, but let me show you why. X equals to negative of negative 1 plus minus square root negative 1 squared minus 4 times 1 times 5 over 2. and that's positive 1 plus minus square root 1 minus 20. And what does that give you? That gives you 1 plus minus square root of negative 19 over 2. And because you have a negative inside the square root, there's no solution. What does that mean? That means for the entire number line, there's only one interval. The entire number line, negative infinity to positive infinity. So either for all reals, this is true, or for all reals, this is not true. Okay, so let me try to explain this again. If you had solutions, those solutions would be put on this number line, and you would have a bunch of different pools where you take samples from them, right? But we don't have any solution, so we just have a single pool, and you just have to pick one number and pick a sample number, and then you just test this. If it works for all numbers. If it does not work, it does not work for any numbers. So let's see. If you plug in 0, I'm going to take 0 as my sample number. So my sample will be 0. At 0, if you plug in, I chose 0 because this is the easiest, right? That gives you negative 5. Is this bigger than 0? Well, no. So because it's a no, it doesn't work. So for D, there'll be no solution.